conditions on a company's job sites. Let's see what happens when I plug in this Compal asset tracker and see what happens. Now, keep in mind, this application has never seen this device before, so it has no code written to support it. So, if we look at the new devices here, you can see a new device has arrived, and over here on this control, it's already figured out how to map its location. And when I click on the device page view, I can see the measurements from the various sensors of this device have automatically been populated, and data is already flowing into this time series graph in IoT Central. And if I click on settings, you can see the settings this device supports. We can see things like the sampling rate, turning on and off tracking, or setting the battery alert levels. And in the properties settings, you can see things like the firmware version, the manufacturer. This has all been populated by the plug-and-play descriptor. All of this just showed up for the user in IoT Central without writing any code in our application. When this device was first connected to IoT Central saw that it had an IoT plug-and-play interface, and it dynamically pulled the device capability model from the device, and it started using that interface to populate information that it knew about, things like location, things like that it had sensor measurements, things like settings and properties. So Compal's device was immediately usable by this application without writing any new code. Now, let me show you how Visual Studio Code let's look at the device capability model in Visual Studio Code. So, here you can see some simple XML that describes this device capability model for the device. And you can see here, here's the example of like the Z-axis accelerometer data from the device. So it's a pretty simple way to describe the interface of how your data shows up in an XML, in this IoT plug-and-play interface. Now, we're working on a new feature in Visual Studio where we can actually take this file, and if I take this XML file and we build it as part of our project, what we're going to do is automatically generate the code for your device to implement this plug-and-play interface. And there we go. So you would just take your sensor data, bind it to these Gitter interfaces, and take it and put it into your device, and you now have a plug-and-play compliant device. If you want to support more interfaces on your device, you just take the XML for those interfaces, put them into the device capability model, and ask Visual Studio to generate that code for you. Very easy. Now, that was a relatively simple device, an RTOS-based device. Now let's take a look at a more sophisticated device, perhaps the most sophisticated device, that uses Azure IoT Edge and cameras to perform AI vision on the edge. And let's see how we can leverage Azure IoT plug-and-play for that. This is a new device from Lenovo, the ThinkSystem SE350 Edge Server. It's a great example of an Azure IoT Edge device that's capable of bringing an incredible amount of compute to where the data is. This particular device has an NVIDIA Tesla T4 chip and has all the horsepower we need to do accelerated machine learning models on the edge. As Rodney mentioned earlier, cameras combined with compute and AI are really the ultimate sensor because they can do things and understand things that normally humans can only do. We're going to connect 16 IP cameras to this Lenovo Edge server and show how the NVIDIA DeepStream technology and Azure IoT Edge can take AI models that have been trained in the cloud and deploy them down onto the edge, where this single edge server can then perform inferencing on all 16 of those video streams simultaneously. An incredible 1080p, 30 frames per second for every camera. And then we're going to use plug-and-play interfaces on this for the edge server and the IP cameras to expose the video streams and the inferencing results from them. So, let's take a look. Here we have an IoT Central application for a digital distribution center. In this demonstration, The machine learning algorithms are looking at packages as they flow through our digital distribution center. And they're checking those packages, whether they're properly labeled, whether they're being properly sorted, or if there's any damage to any of the packages. So, if I look at this belt here that has an error, I can see all 16 of the cameras with AI overlays. And if I click on this specific camera that's showing an error, I can see a video of just that camera, and I can start to see the events of the errors that are coming by on that conveyor belt. So this is just an incredible example of what's becoming possible with edge computing, and why we're so excited about the hardware partnerships to bring technology like this to market. The ThinkSystem SE350 with Azure IoT Edge is going to be available later this summer and come with your choice of Windows or Linux. And at the same time, the NVIDIA DeepStream technology is going to be available as an edge solution in the Azure marketplace. So, I've now shown an example using IoT Plug and Play with an RTOS-based device, and then an example with a Linux device running Azure IoT Edge. Now, with both of these examples, it still requires you or your customers to write device code and to implement that into the image of the device. But we're going to show you how with Windows, we're making this even easier. We're building a solution with Windows where you can create a plug-and-play device without writing any code on the device or in the cloud. We call this IoT Plug-and-Play Bridge for Windows. And what it does is take devices and sensors that Windows can see using Windows Plug-and-Play, and it exposes them as IoT plug-and-play devices the cloud services can see. Let me show you how that works. Here I have an Advantech industrial PC. Oops, I skipped by my industrial PC. Let me just go back to that. There we go. Here I have an Advantech industrial PC running Windows IoT. And I'm going to connect it to an environmental sensor over a Modbus network. So this is just like you would see in any smart building solution. Now, Windows already has support for this Modbus device and thousands of other devices. And we're going to show you how, with some simple configuration, you can expose any of these devices as IoT plug-and-play devices. Okay. So, I'm using Azure IoT Device Agent on Windows to automatically connect my device to Azure. And here you can see an Azure IoT Central dashboard for monitoring environmental data in office buildings. Because I have the plug-and-play bridge installed and configured on the industrial PC, data from the Modbus sensor immediately starts flowing into my dashboard where it can be monitored, alerts can be set, and actions triggered. And once again, I can do things like see how what commands are available for this device. I can also see what properties have been set for this device, its firmware version, manufacturer, etc. And I get all of this data flowing. All I had to do was tell the plug-and-play bridge which of the devices connected to Windows I wanted to turn into IoT plug-and-play devices. And then I just had to tell them how to expose that data in the device capability model. And guess what? You can do that once again using a simple XML configuration file. And here it is. Here at the top of this file, you can see how I've told the Azure Device Provisioning Service which Azure service to connect to, whose account to connect to. And I've also told it which plug-and-play device capability model to use for this device. And then I can start mapping the Windows-connected devices to the IoT plug-and-play interface. So here, I specified that I wanted to expose the device on COM port 1, and I can show how to expose the serial bus commands. Here, 40001 for carbon monoxide,